Kita nggak ada invited ya Mas ya, nggak ada invited speaker kan ya?
Iya Pak, nggak ada Pak.
Oke, baik. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, ladies and gentlemen. Good afternoon to all of the participants of SMIC 2022. Welcome to this parallel session. And my name is Tia Budi from Department of Chemistry, and it is an honor for me to be a moderator for this parallel session. And Bapak Ibu, in this room we are going to have 14 presenter who will be deliver their presentations by video presentation. And in this session, I also going to invite all of the participants for a question and answer session after the video presentations. And before the session begins, please allow me to inform you the detail of decisions for all of the presenter. Please make sure to use the right name format as we informed before. And please kindly check the parallel session schedule to ensure your presentation time. We hope that you are all in the right room. And this is the room 17. And please join the parallel session. Since your presentation is scheduled at the beginning, please do not wait until it is time for your presentation to join. And as I told you before, that the presentation video of each presenter will be played by the technical team, which is Mas Muhammad, with durations of 10 minutes. And after that, we are going to have a question and answer session that I'm going to invite of the participant to deliver their question. And for that, I hope all of the participants should be ready for discussion. And all of the presenter will be allowed to turn on the microphone during question and answer session. So during the video, the presenter should off the microphone to avoid any noise. And then all presenters are also expected to turn on the video camera and to use the virtual background of the conference. If you have any technical issue, you can write a text in the chat box. And for the audience, please keep the microphone mute when the presentation is going on. And you can on the microphone in the question and answer session. And also for question, you can text in the chat box. Okay, ladies and gentlemen, let us start with our first presentation. Will be conducted by Dr. Jarani Taher with the paper entitled Optimization, Scaling Up, and Establishment of Herbal Processing Technology for Production of Bioactive Extract from Selected Malaysian Medicinal Plant. Now we are going to see the video before question and answer.
Yeah, I have a live presentation anyway. Yeah, let me share my screen.
Okay.
All right. Have you seen it?
Yeah. So you are conduct your presentation?
Yes.
Not by video?
No.
Oh, okay. That's
right.
okay. Please. Time is yours. You have 10 minutes for presentation, Doctor.
Okay. Thank you for the moderator for the kind introduction. Assalamualaikum warahmatullahi wabarakatuh and good afternoon, everyone. I'm Zari Mak Tahir. I'm from University Technology Malaysia, Skudai. I would like to share some of my work been done in our institute, basically on optimization and how we do scaling up. And also we established the herbal processing technology for the production of bioactive extract from selected Malaysian medicinal plant. So where in this institute, we have facilities from large scale to the pilot scale. So this is what we are coming out with this research study. So we understand that Malaysia or Indonesia have a mega biodiversity, flora and fauna. So as we see that the herbal remedies, they play important roles in the maintenance of the production of throughout the history of mankind. We know that over 50% of modern clinical are sourced from various plant extracts and have been used as a supplement and also for nutraceutical. However, these medicinal plants continue to be important source of new therapeutic. However, the scientific validation remains inadequate due to the lack of adequate plant material, execution of suitable high throughput screening bioassay, bioavailability of bioactive in large quantity, and finally, the regulatory approval and clinical trial. Therefore, our strategy is to improve the quality of phytochemicals during processing, which is the main objective of my study. Therefore, we actually are looking into the phytochemical and how to retain the phytochemical and nutrient content, which is normally is damaged by the processing. So, which is, we know that at the end, it will affect the final product quality. So the objective of my work is to optimization, scaling up, and establishment of herbal processing technology production of chemical to production of chemical marker extract from 4 herbal, which is Piper bitter, which is known as sireh, Piper sarmentosum, kadok, Gyanura procumbens, sambung nyawa, and Melastoma malaterium, which is senduduk. I think all of you know this herbal very well. Okay, this is raw material that we use. We targeted this 4 because this is one of the natural agenda in Malaysia where we have a certain selected plant extract. So okay, and we focus on this 4 for our study. We know that Piper beetle is just sireh. It's being used in our traditional use as an anti-inflammatory and in it's a traditional pox. And for Melastoma malaterium, which is senduduk, I think we can find it everywhere in South Asian country. So it treats a various of ailments such as diseases, for example, diarrhea, dysentery, hemorrhoids, cuts, wound, and stomach ache, flatulence, and so on. Same goes with the Piper sarmentosum. This is from the same with the Piper. It's a Piperaceae family. So it has medicinal properties such as antibacterial, antiprotozoal, antioxidant, antimalarial, and lots more. While the sambung nyawa is quite rare, I think probably in Indonesia they have familiar with this Gyanura procumbens. This is quite popular plant in South Asia, and it's been used to treat migraine, diabetes, inflammation, and kidney disease. So this is for the raw material that we use in our study. And then we move on to the research methodology that we handling with. So for the raw material, normally we send for a plant authentication so that we will understand the species of the plant that we use throughout the study. And then we come up with a pre-treatment for each of these herbal. And we go for the optimization of the extraction based on yield and chemical marker that we did in our laboratory scale. So it's from laboratory scale to the pilot scale. So in between, we have some process that we have to carry out before we produce in large scale. So, and then we analyze in vitro the bioactivity such as antioxidant and anti-inflammatory. For the antioxidant, we have 3 technique, which is PPPH, FREP, and also ABTS. And for anti-inflammatory, we have enzymatic assay, which is lipoxygenase, xanthine oxidase, and hyaluronidase. Okay, all of these we will go through the small scale. This is all small scale. And then we optimize using response surface methodology. And then we start moving on to using a pilot scale. Okay. Okay, based on the result, the findings that we found that after we send it for plant authentication, is approved that the plant that we send, which is Piper betel and Piper samanthassum, which is 4 to 6 months, is a scientific is approval that they have is a Piperaceae family. Same goes with the Piper samanthassum, which is Caddo, and also for the Malastoma is a Malastomaceae. And Gynura percumbens is a variety is different. This is right? Okay, all of this is confirmed that the plant that we are using is the same as we expected, which is and we conducted this plant species to Institute Bioscience in UPM to confirm, to approve the plant that we use is authentic. Okay, in as of a finding, this is a 3D graph interaction between a raw material to solvent ratio and extraction. Duration on the extract yield, so on Piper betel, we can see that this is the extraction, the yield, which is have a decrease, especially for the hydrochemical, which is the phytochemical. And while you are extracting or extracting further, the amount of phytochemical will decrease, which is normally is around 120 minutes. So in that case, it is degradation will occur after so long in the extraction. Some of the component, which is hydrochemical, will degrade after a while. This is the 3D graph interaction between raw material that we use and solvent, which is we using this time is a Sendudo. Okay, we can see that after a while, during the extraction time, the concentrate that we get is start to degrade, and it because of when the larger ratio is used, the capacity of solvent to diffuse into the plant is higher, so that it will accelerate the absorption of phytochemical from the cell. Okay, and that's why the use, if we extend the more time, actually don't have any effect on it. Okay, this is a total phenolic content and total flavonoid content. While we know that most of these 4 herbs have a high content of flavonoid and phenolic, we have to check whether the amount is correct, so that we know that the betel, Piper betel, have a highest, we obtain highest flavonoid content compared to, but then all of these 4 have a quite significant data where we have a high flavonoid content. For the phenolic content, we can see that the Samanthassum, which is Caddo, have a quite lower amount of phenolic compared to the betel, which is 96.72%. Okay. And we move to the antioxidant activity. When we know that the flavonoid and phenolic, we check the antioxidant activity for these 4 herbs. We found out that using essentially for antioxidant activity is technique dependent, where we have a different data that we gather. So for the DPPH radical scavenging assay, we obtain quite significant amount of activity, antioxidant activity, which is around 22%, while DPPH for laboratoricum, which is Nodo, is less than the others, which is 2%. For the FRAP reducing power assay, so the betel still we got highest obtain of the FRAP reducing if using with this FRAP technique, we got quite high amount of the antioxidant activity. So, okay, and then we are trying to use another technique, which is ABTS scavenging assay. So each of these have a significant amount. So if using ABTS scavenging assay, we can see that the amounts of procumbens is quite high, which is 26, which is different from the other three herbal. Okay, and then after we make some testing on antioxidant activity, we looking into the anti-inflammatory. So we using enzymatic assay for this. We have 3 activity, we see lipoxygenase, xanthine oxidase, and hyaluronidase. So for this raw material, we can see that for the high lipoxygenase, Piper beetle have a quite significant anti-inflammatory, which is around 50 to 55%. And while the Piper samanthassum is less, which is 1.9, okay, which is, although they have same family, but it have less anti-inflammatory activity compared to the Piper beetle. Okay, for this lipoxygenase, we can see that Piper beetle and Melasthoma malabricum have a quite significant activity for anti-inflammatory. While for the xanthine oxidase, if you can see that Sendudok for Melastoma, it quite high, which is around 87%. And then we got less for Piper beetle for if using xanthine oxidase as our technique. And for the hyaluronidase, which is the value for this is around, for Piper beetle is around 34%. So we can see that previously that most of the plant have antioxidant activity. It could be due to the highest flavonoid and phenolic content for the plant. So then we expect that it can have, the result indicates that most of the plant that we studied have a quite high antioxidant activity. Okay, we are talking about lab scale just now. Okay, now we move on to the scaling up extraction process. So in a lab scale, we can adjust everything, we can control everything, but in a scaling up process, we need to be careful. Therefore, we do a dimensional analysis for scaling up. This for herbal, we using a regression analysis to carry out and perform.
Sorry, Dr. Zarani.
Yes?
You still have 1 minute for
okay. Okay, good. Okay, and then we have 3 models: Sherwood number, Parental number, and a combination of a Sherwood and a Parental number. So this is the scaling up process where we do from the 1 liter to the 200 liter. So this technique is in a turbulent condition. So as we can see that this model validation, when we do calculation, for the Piper beetle, Piper samanthassum, and Gynura procumbens, they have fit with the model for the Sherwood, combination of Sherwood and Parental. However, for the Melastoma, which is Sendudok, they are fit for the Parental number only. Okay, as a conclusion, we know that the content of hydrocarbon crude obtained in this work is around 6.5%. And the for the samanthassum, is the beta sitosterol is around 0.7%. For the sambung nyawa, we got chlorogenic acid around 6.1%, while the Sendudok, quercetin is around 3.0%. So all the result investigate plant have a high antioxidant activity, and we see that when you do the extraction in the scaling up, the percentage of error is around 4.48% for beetle. Samanthassum is around 2.8%. For Gynura procumbens is a 9.1%. And for the malabritum is around 4%. So if we know that the error that we have when we do calculation during the model, we can see that it is a possibility to be done, and we can say that the pilot scale was successfully conducted using the dimensional analysis. Okay, as for now, I would like to thank Ministry of Agriculture and Agro-Based Industry Malaysia under this for financial support, and also for Institute of Bioproduct Development for the providing the facilities and infrastructure for us to run the experiment. With that, I thank you.
Okay, thank you very much, Dr. Zarani, for your very interesting presentation. And now we move on to the question and answer sessions. If any question, please raise your hand, ladies and gentlemen. Any question? Also, you can text on the chat box if you have some question for the presenter. Any question for Dr. Zarani? Bapak Ibu, ada pertanyaan? You may raise your hand, on. You can text on the chat box if you have a question for the presenter. Okay, Dr. Zarani.
Yes.
You talk on bioactive extract, and yes, one of the investigation you conduct is the antioxidant activities of the extract, and you present some method to evaluate the antioxidant activity. Have you ever tried to use ESR for the evaluation of antioxidant activities, Dr. Zarani?
for the time being, we for that time frame, we managed to do that 3 only because we have another for scaling up. It takes some time because of the limited time and resources. We didn't have much time to do other Untitled method, but we love to do that in the future. Thank you for the consideration. And however, the grant was already closed, so that but then hopefully we can do as a part of our research in the future. Thank you for that suggestion. Yeah.
Okay, thank you. It is very interesting actually because I also conduct my research on gold nanoparticle. It's also intended for antioxidant material. So my question, is there any ESR facilities in UTM, Dr. Zanani? Maybe I can send sample to your lab.
To be honest, that in our institute we don't have that ESR, but then in the university we have center lab where we can send some sample over there, and then maybe we can have a collaboration for that particular experiment, doctor. Yeah.
Okay. I think interesting. So it is mean that
in IBD itself we don't have that facilities, but in UTM, yes, we do have. Yeah.
Okay.
Yeah.
Okay, I will contact you later, Dr. Zarani.
Yeah, yes, please. Yes.
Okay, thank you so much.
Right.
Okay, Dr. Zarani, thank you for your presentation
so
and your discussion. I will contact you later about the ESR. And Bapak Ibu, now we are going to move to the next presenter, which is Ibu Dr. Neneng Siti Silvi Ambarwati. Ibu Neneng?
Yes.
Are you going to deliver your presentation directly or by video?
Or by video. Okay.
Okay. Mas Muhammad, please play the video of the presentation.
Welcome to Science and Mathematics International Conference 2022. My name is Neneng Siti Silvia Ambarwati and I am the lecturer in Engineering Faculty, Universitas Negeri Jakarta. Thank you for coming today. Good afternoon, ladies and gentlemen. I'm looking forward to talking with you today about in silico molecular docking study of isolated compounds from Cruciaceae family as SARS-CoV-2 main protease inhibitor. The severe acute respiratory syndrome-related coronavirus 2 or novel coronavirus COVID-19 infection has been declared world pandemic, causing a worrisome number of deaths, especially among vulnerable citizens in 209 countries around the world. Although several therapeutic molecules are being tested, no effective vaccines or specific treatment have been developed. In overcoming pandemic COVID-19, it is necessary to develop drugs with a vital protein target approach to the life cycle of the virus. The main protease impro plays a dominant role in the process of polyprotein coffee, which mediates the assembly of a replication transcription machine. Therefore, MPRO is an ideal antivirus target. There is a need for drug development for the treatment of SARS-CoV-2, including from natural ingredients. Screening isolates from natural materials can be done by silico tests. The last few years, a new computing devices has been used to speed up and optimize the process of drug discovery. This method can reduce the cost of drug development by 50%. Bioinformatics has shown a significant increase in the development of computing and web devices that can be applied to new drug design. The nature of absorption, distribution, metabolism, and excretion, and physical-based pharmacokinetic models make it easy to understand the pharmacokinetics properties of new compound. Therefore, in an effort to immediately propose the discovery of natural products that can be used against SARS-CoV-2. In this study, we conducted an analysis of molecular docking and admitox with 34 isolates from the family Clayson medicinal plants. Material and methods on the basis of pharmacophoric mapping, docking scores, binding energy, and binding interaction with active sites residue cysteine 145 and domain 2 from SARS-CoV-2 receptors main protease. In this study, 34 isolates of compounds descreening from the combined PubChem database had been prescribed with the main protein SARS-CoV-2 using Autodoc 4.2.6. We obtained 34 isolates of plant compounds from the Clayson family from the research result and from the literature. The methods of molecular docking carried out are as follows: preparation of native ligand and receptors, test ligand preparation, and molecular encoding. Research result: compound isolates of the Clayson family have been collected from the library as many as 34 compound isolates, including 4 compound isolates obtained by researchers from the isolation of the plant Garcinia latisimamic, namely amintoflavone, robustaflavone, 6-deoxyjacarbine, and fridolin. The next isolates were mosasaxantone and asmasanton from Garcinia rigida leaves, stigmasterol, lupeol, 2 terpenoid compounds from the plant Garcinia rigida, beta-sitosterol and botulinic acid compounds from the stem of Antidesma buneus L, ananixanthon from the root bark of Salatri, Calopilum sauletri. 3 compound isolates were obtained from the leaves of Garcinia dedelantherapir, calanolide A, calanolide B, and solatrolite are compound isolates from the stems of Calopelum incrasaptum and the leaves of Calopilum tetrapteromic. The picture in the center shows that comparison between native ligand before in blue picture and after in red picture, docking with an RMSD value of 1,306 less than of 2 angstrom. The inhibitory activity of the SARS-CoV-2 receptor improved against 33 xanthone-derived compound isolate from the genus Garcinia using the in silico molecular docking study method. This study was conducted with the aim of predicting the potential inhibitory activity of the SARS-CoV-2 receptor improved based on the interaction and form of binding between the test ligand and the active site of the receptor. The structure of the SARS-CoV-2 main protease is composed of 3 domains consisting of domain 1, domain 2, and domain 3. Histidine 41 residues in domain 1 and cysteine 145 in domain 2 are active sites of the SARS-CoV-2 main protease receptor. And we studied 2 forms of the target protein of the SARS-CoV-2 main protease with PDB-ID 6LU7 were obtained independently from the protein data bank on the website https://rcsb.org. Basically, the 2 proteins are the same, but only differ in the native ligand, namely Z3179168 for 5R84 and N3 lopinavir for 6LU7. Due to these differences in native ligands, it causes differences in binding, conformation, and interaction of receptor protein residues, especially in the active site domain of the receptor. Based on the redocking result of the 2 native ligands, each of which was compared before and after docking to verify the value of the root square mean deviation RSMD of the lowest energy of the backbone atoms and their interaction with the active site of the receptor, which is 0.978. Gibbs free energy minus 9.18 kilocalorie per mole in 36 cluster for 100 rounds with a tolerance of RMSD 2 angstrom as shown in figure. Discussion. Interaction before docking with salt interaction on amino acid residues, especially on the active site on his 41 in domain 1 and cis 145 in domain 2, the native ligand entry forms a conformational pi-alkyl interaction with his 41, covalent bond interaction with cis 145, and interaction with other residues. While in the test ligand, based on the binding energy value, there were only 4 compounds that had a lower binding energy than the native ligand, namely amintoflavone compound, fucogiside, ananic xanthan, and canopilol. Meanwhile, based on conformational interaction with the active site of the receptor, only amintoflavone and ananic xanthan compounds have direct interaction with the active site of the receptor on residues of His41 and Cis145. As shown in figure, amintoflavone compounds form a PP-shaped interaction with His41 and a van der Waals interaction with Cis145, as well as interaction with other amino acid residues. Meanwhile, ananic xanthan compounds form an interaction conformation in the form of alkyl and pi-alkyl to His41, and at Cis145, it forms hydrogen and pi-sulfur bonds. Meanwhile, fucogiside and canopilol compounds did not form conformational interaction with the active site on the His41 residue, although they had interaction with other residues and had lower binding energies than native ligands. Therefore, it can be concluded that of the 34 compounds from the Cruciaceae family, amintoflavone and ananic xanthan compounds have very good potential to be further developed as major protease inhibitors of SARS-CoV-2. Conclusions. In conclusion, the docking results show that amintoflavone, ananic xanthan, canopilol, fucogiside have a stronger interaction potential and bond between ligand and receptor compared to native ligand, lopinavir, and is very feasible to be continued for in vitro and in vivo tests. However, the results of this study are still limited in prediction based on calculation or mathematical calculation of interaction at the molecular docking level. It is still necessary to continue in silico analysis at the molecular dynamic level. Thank you.
Okay, thank you, Dr. Sylvie, for your very nice and informative presentation. Bapak Ibu, any question for Dr. Neneng? The topic is very interesting. It is about the COVID-19 and how to find some bioactive material for the inhibition of the virus. So, any question? Dr. Neneng, one question from me. You saw in your slide the structure of the, let's say, the molecule, right? Did you do such kind of measurement, like for example, carbon NMR or proton NMR to determine the structure, or do you do the others method to get the structure?
Yes, thank you, Pak Dr. Setiabudi. I have my isolate 4 compounds, actually 4 compounds. I get it by NMR, but I measure my NMR in University of Malaya, and I use spectral photometry to UV, and in NMR, so I use CNMR and HNMR too.
Okay. Carbon and proton NMR, right?
Yes. Two dimension, yeah.
Okay. Thank you very much, Dr. Sylvie. Due to the time limitations, we are going to move to the next presenter.
Yes, you're welcome.
Okay, which is Mbak Anissa Aulia. The title of the paper is Electrodeposition of Gold Nanoparticle from a Low Electrolyte Concentration and its Application for Ethanol Electrooxidation. Mbak Anissa, are you going to deliver your presentation directly or by video, Mas Muhammad? By video or okay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Greetings everyone. I am Anissa Aulia from the Center for Science Innovation. And today, I will present our work about electrodeposition of gold nanoparticles from a low electrolyte concentration for ethanol electrooxidation. First, I'm going to introduce an energy. Energy is an essential thing to fulfill human needs. Therefore, it is necessary to find alternative energy sources that are sustainable and eco-friendly. One of the sustainable and eco-friendly fuel is ethanol. Ethanol has many of benefits, such as higher energy density compared to hydrogen gas and methanol, lower toxicity than methanol, and can be produced on a large scale by biomass fermentation. Therefore, this fuel is widely studied for the manufacture of fuel cells and known as direct ethanol fuel cells or DFC. It is known that platinum and palladium are a good catalyst for DFC due to their fast electrokinetics. However, catalysts based on both are expensive and scarce. Furthermore, platinum is easily poisoned by adsorbate in the media in ethanol electrooxidation. The excellencies of gold as a catalyst compared to the two metals are lower cost, abundant on earth, lower toxicity effect, and high reactivity for ethanol oxidation in alkaline media. Therefore, various methods have been used to synthesize gold nanoparticles, such as by chemical reduction method, biosynthesis, sonochemistry, seed-mediated growth, and electrodeposition. Among these methods, electrodeposition is a simple, low-cost, can be conducted at room temperature, and produce a uniformity layer. Based on previous work, electrodeposition of gold nanoparticles usually conducted with high concentration of electrolyte, or when it is using low concentration electrolyte, additives were usually added. Unfortunately, this can increase the synthesis cost. So, in this work, we would like to synthesize gold nanoparticles from an additive-free and low-concentration electrolyte and then measure its catalytic activity on ethanol electrooxidation process. Now, here's the method for electrodeposition of gold nanoparticles. First, the fluorine doped oxide as a substrate were cleaned with ethanol and distilled water, and then dip it into the tetrachloroauric acid rehydrate, and then connect the electrode and electrochemical cell to a potential state, and then set up the electrode deposition parameters, and then run the experiment. After the experiment finished, there will be a gold nanoparticles deposited over the FDO, and then rinse the sample and dry it. Next is electrochemical properties test of the gold nanoparticle. For the sample, dip to a potassium chloride and then connect to an electrochemical impedance spectroscope instrument, and then set up the EIS parameters and then run the experiment. Then is catalytic activity measurement. First, gold nanoparticles dip to an ethanol containing sodium hydroxide and then connect to a potential state, and then set up the cyclic photometry parameters and then run the experiment. Now we come to the result and discussions subgraph. This micrograph indicated that the deposited gold nanoparticles have a spherical base shape. Uniquely, some particles tend to agglomerate and form 3D particles that have protrusion upward. This is an EDX spectrum from gold nanoparticles. This spectrum shows the presence of gold in the sample, and other elements from the substrate also appear, such as tin, aluminum, oxygen, carbon, and silicon. This is the Nyquist plot from the EIS test. This plot shows that gold nanoparticles has a lower charge transfer resistance than FDO, indicating the electrochemical catalytic reactivity of gold nanoparticles. And this is the cyclic voltammogram from the gold nanoparticles. In the forward scan, an oxidation peak appeared at 0.2 volt. This is the peak, which was a characteristic of ethanol electroxidation by gold. Meanwhile, the reverse scan showed an oxidation peak at 0 volt. This is the peak that indicated the electrochemical oxidation and carbon monoxide and another adsorptive species. And the conclusion from this research is gold nanoparticles with a 3D spherical base shape were successfully synthesized using the electrode deposition technique. Based on the EIS test, gold nanoparticles has a smaller charge transfer resistance than FDO, indicated the electrochemical catalytic reactivity of gold nanoparticles. From the cyclic voltammogram, gold nanoparticles show an oxidation peak at 0.2 volt with a current density of 1.83 milliampere per centimeter square, indicated the ethanol electroxidation process in the system. The reverse peak that appears at 0 volt indicated the presence of electrochemical oxidation of carbon monoxide and other adsorbate species. Then, in the last, I would like to acknowledge Lembaga Penelitian dan Pengabdian kepada Masyarakat Universitas Negeri Jakarta for the research funding through Hibah Pusat Unggulan Iptek tahun 2022. That's all from my presentation. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Wassalamualaikum warahmatullahi wabarakatuh. Okay, thank you very much, Mbak Anissa, for your very nice presentation. Any question, ladies and gentlemen? Bapak Ibu, ada pertanyaan? Okay, please raise your hand, and also you can text the question on the chat box. Okay, Mbak Anissa, you studied the electrooxidation of ethanol by using the gold nanoparticle as catalyst, right? So, and yes, in your presentation, you saw the results from the result of the catalytic activity of the gold for the ethanol electrooxidation. So, have you compared it to other catalysts like platina, as you said in your introduction, or palladium, for example? Which is better?
Okay, actually right now I am doing another research about electrooxidation of platinum nanoparticles from for ethanol electrooxidation, and I have compared both, and the result is platina is have a higher catalytic activity than gold, and is that is the answer.
Okay, okay, thank you. But how about the others? I mean, the catalysts that people reported in their work, like palladium or platinum. I mean, have you compared your result with the other work, the other work that reported by other researchers?
Yes, I have and and from the another work, the activity of electrooxidation ethanol is good by the materials such as gold and platinum, or gold and palladium, or platinum, tin, and like that, something like that.
Okay. Okay. Thank you very much, Mbak Anissa, for the discussion. I hope you will be success in your research. And we are going to move to the next presenter, which is Ibu Kurniawanti. But before we hear from Bu Kurniawanti, Mas Muhammad want to have a picture of us. So, ladies and gentlemen, please open your camera. We are going to have a picture. Mas Muhammad, silakan. Bapak Ibu nanti nggak dapat door prize yang nggak on kamera, ya. Oke. Silakan. Please open your camera.
Everyone your camera.
Oke, silakan Mas Muhammad.
1, 2, 3. 1, 2, 3. Oke, terima kasih.
Oke. Terima kasih Mas Muhammad. Oke, thank you Bapak Ibu. Now we are moved to Ibu Kurniawanti. I guess Bu Kurniawanti wanted to share the presentation by video, right?
Right.
So Mas Muhammad, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. This time I will present our research with the title Antioxidant Activities of Biflavonoid from Indonesia Araucaria columnaris lab. My name is Kurniawanti and this our team. This research is collaborate with IPB University and Universitas Negeri Jakarta. The following is an outline that will be explained. The first two introduction. The background of this research is plants are one of the potential source of medicine and are considered the pioneer of modern medicine. The therapeutic properties of plants are associated with compound or bioactive ingredient contained in plants. Antioxidant is one of the therapeutic properties of medicinal plants. One of the secondary metabolic compounds that have the potential as antioxidants are flavonoids. Biflavonoids are flavonoid dimers linked via carbon-carbon or carbon-oxygen-carbon bonds, and a group of biflavonoid compounds that have antioxidant activities such as cupressuflavone, amentorflavone, agatisflavone, robustaflavone, hinokiflavone, potifulgenen, and rustaflavone. However, a report on biflavonoid bioactivity as antioxidant is still limited. Biflavonoid can be found in various higher plants, and one of them is the genus Araucaria. Araucaria columnaris is a species belonging to the genus Araucaria, which is reported to contain biflavonoid compound. And this species is endemic to New Caledonia and grows in warm climates, prefer ultrabasic schistose and calcareous soil. This species has activity as antibacterial, antiviral, antifungal, antioxidant, and anti-cancer. There are 11 reported biflavonoid compounds derived this species from India and Hawaii. and several plants of the genus Araucaria grow in Indonesia. One of them is Araucaria columnaris, which grow in the Bogor Botanical Garden, West Java, Indonesia. To date, the reported study on the isolation of biflavonoid from the leaves of this species is Araucaria columnaris, which grows in Hawaii and India. In addition, research on the compound content and biological activity of biflavonoids from the Indonesian Araucaria columnaris plant has not been reported. Different factors in growing conditions such as temperature, humidity, and geographical condition can affect the content of secondary metabolites. Therefore, Araucaria columnaris in Indonesia is very potential to study its compound, especially biflavonoid, which have antioxidant activity. In this research, we follow common method for isolation of a secondary metabolite from a plant. First, we extract the leaf powder of Araucaria columnaris from the Bogor Botanical Garden, Indonesia, with acetone, and the crude extraction of acetone is followed by a dechlorophyll and detanning process, and the acetone fraction was examined for its antioxidant activity. Then the acetone extract was also separated and purified by using various chromatography techniques to yield isolated compounds. Next, the structure of isolated compound of that were elucidated based on 1 and 2 dimension NMR and infrared spectral data, UPPs, and LCMS. While the antioxidant activity using the DPPH method. And next, the result and discussion. Compounds that have been isolated from the leaves of Araucaria columnaris from Indonesia are 4', 4', 7, and 7 double prime theta orthometic cupressylflavone, and 4', 7 double prime 3 orthometic cupressylflavone, and 4 triple prime 7 the orthometic cupressylflavone. This compound have been found in other species in the family Araucariaceae. However, compound of C is new biflavonoid compound in species Araucaria columnaris. The following is a discussion of the characteristics of compound C. The first, from infrared spectrum, shows that compound has aromatic double bond group, epoxide strain, and a carbonyl group. And for UV spectrum, biflavonoid are a flavonoid dimers containing aromatic compound with a conjugate system and can show strong absorption band in the UV region. Flavonoids have two groups in their structure, namely benzoyl and cinnamoyl group. The table shows band 1 and 2 of compound C show indication of flavone compound. Addition of sodium hydroxide show a bathochromic shift, which indicates hydroxyl ionization at carbon 4. And the addition of aluminum chloride indicates the presence of chelation of aluminum with hydroxyketone and orthohydroxy. From LCM spectrum, so molecular weight of compound C is 567, and with a molecular formula C32, H22, and O10, it has 22 double bond equivalent, consists of 4 aromatic ring, 2 cyclic, 2 double bond group, and 2 carbonyl group, with each commonly as biflavonoid type. From proton NMR, so 3 sigma doublet with orthocoupling of 2 aromatic rings B and B prime, which para substitute and represent a proton. And then 3 singlet aromatic signal and represent for a proton. And then the signal represent to methoxy group. So proton NMR show 8 signal represent 22 proton. Next, from a carbon NMR, so 2 signal of carbon group chelated carbonyl and 10 of oxyaric carbon, and 13 signal represent 18 sp2 aromatic carbon, and 2 signal of methoxy carbon. So from carbon NMR spectrum, so 28 signal represent of 32 carbon. From two-dimension NMR HCQC, so one bond correlation between proton and carbon. For example, there are correlation proton for a triple prime to C triple prime methoxy and as withdrawn by red. And proton and carbon correlation data are shown in the following table. And from two-dimension NMR HMBC, so to until 3 bond correlation between proton and carbon, and this is as HMBC correlation on compound C. Based on the table, so the NMR spectra of isolated compound also have a high similarity to the spectral data reported by Agusa from Araucaria Hustaini. And the egg double prime copressylflavone dimer bond is indicated by doublet and orthocouplet proton signal, indicating ring B is a parasubstitute, and symmetrical ring indicates that the dimeric bond is not located in ring B. And then the HMBC spectrum showed a correlation between the proton at position 6 and 6 double prime with a carbon egg and egg double prime. Based on the HSQC analysis, so carbon does not show any proton bond to carbon egg and egg double prime, then both carbon are tertiary carbons. Therefore, based on data, so the compound is the cupressylflavone type. Okay, for antioxidant activity of biflavonoid from Indonesia Araucaria columnaris, based on the table, it showed that the acetone extract of Araucaria columnaris lead showed modern activity, and compound A to C showed weak antioxidant activity. Vanillin reported that cupressylflavone compound had higher antioxidant activity than the 3 cupressylflavone derivatives in the study. The antioxidant activity of the compound on the left to the right increased with the increase in the number of hydroxy groups. Therefore, the hydroxy group at position carbon for prime for triple prime 7 and 7 double prime of the cupressylflavone group are thought to increase the inhibitory activity. Finally, from this research, we can conclude that the biflavonoid isolated from acetone of Araucaria columnaris leaf obtained 3 compounds. Compound C was first isolated in Araucaria columnaris. Compound E to C showed weak antioxidant activity with the IC50 greater 100 ppm due to the absence of some phenolic hydroxyl in the molecule. For the acknowledgement, the author would like thanks to Dirjen Pendidikan Tinggi Riset dan Teknologi Kementerian Pendidikan, Kebudayaan Riset dan Teknologi, and then research grant from Department of Chemistry, Bogor Agricultural University, and team this research. Thank you.
Okay, thank you, Ibu Kurniawanti, for your very comprehensive compound characterization. Okay, and ladies and gentlemen, any question for Ibu Kurniawanti? Ada pertanyaan? Boleh bahasa Sunda ini dari Bogor? Please, I can translate it for Dr. Kurniawanti. Ibu Kurniawanti, you studied the antioxidant activity using DPPH, right?
Yes.
How do you conduct it? How do you conduct the measurement? Do you use a kind of spectral, for example, or what? To evaluate the contact from the DVPH, the radical with the compound.
Sorry, maksudnya dihubungkan atau
Bagaimana itu ditentukannya? Kan dengan
sorry.
menggunakan DPPH ya?
Ya,
Oke.
sorry. Ya, betul. Boleh saya pakai bahasa Indonesia saja?
Boleh, silakan.
Ya, jadi saya kan mengerjakan dari 3 senyawa tersebut. Saya kerjakan dengan antioksidannya dengan metode DPPH, kemudian saya dapat IC50-nya. Nah, dari literatur, karena saya tidak mendapatkan senyawa kupresiv plafon, saya bandingkan dengan data dari literatur kupresiv plafon. Kemudian dari situ saya membandingkan hubungan antara structure dan IC50 yang telah saya dapatkan. Ternyata dengan pengurangan hidroksil terutama pada komposisi yang seperti tadi yang setelah saya sebutkan pada posisi 4 prime, terus yang 4 double prime, kemudian 7 dan 7 double prime itu ternyata mempengaruhi dari posisi atau mempengaruhi kekuatan dari antioksidan tersebut. Jadi berdasarkan dari IC50-nya seperti itu.
Oke, baik. Terima kasih. Belum menggunakan metode lain ya?
Belum. Nah, itu tadi saya sempat melihat yang lain. Mungkin saya akan mencoba untuk yang menggunakan metode PrEP karena mungkin kelarutan dari si biflavonoid ini kebetulan sangat sulit larut di metanol. Kemarin saya sempat menggunakan DNSO, jadi kemungkinan saya mau mencoba kembali dengan metode lain seperti PrEP dan ABTS.
Oke, baik. Terima kasih banyak
pakai
Bu
bahasa Indonesia.
Ya, tidak apa-apa. Ini orang Indonesia semua. Yang dari Malaysia juga mengerti bahasa Indonesia. Insya Allah ya. Baik, terima kasih Bu Kurniawanti. Semoga sukses with your research. And now we have to move to the next presenter, Mas Wisnu Widikdo. Okay, Mas Wisnu Widikdo, are you there? Oh ya, yes. Okay, Mas Muhammad, is it the video presentation? Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wisnu Widikdo, and this is our team. I want to present about our research, and the title is Optimization of Silver Nanoparticle Synthesis from Finger Root Rhizome Extract. Silver nanoparticles have a broad bioactivity, including antibacterial, antifungal, and anti-cancer. Reducing agent for synthesizing silver nanoparticle can come from chemical reagents such as sodium borohydrate or trisodium citrate. Reducing agent also came from natural sources such as fungi and plants that have a phenolic compound and flavonoid. Phenol compounds can act as a bioreductor in the reduction of metal nanoparticle. This is the example of the plant that have used as a reducing agent. We choose fingerroot or temukunji as a potential bioreductor because it has high phenolic content, especially acetonic extract. Many silver nanoparticles now produced with UV irradiation method because it is effective and non-costly method. There are some examples of research that use UV irradiation and also the bioreductor. The purpose of this research is to synthesize silver nanoparticle using fingerroot rhizome extract as a bioreductor with UV lamps at 366 nanometer and optimizing its yield with box band design. The method first, the dried finger root simplicia is macerated and weighed 0.2 gram and diluted with acetone. After the extract is dissolved, the extract then mixed with silver nitrate. The solution then added with sodium hydroxide until the exact pH and then irradiated with UV lamp for exact time. The silver nitrate formation is indicated when the solution color changes from yellowish brown to dark brown. The solution then analyzed with spectral photometer to measure the absorbance. Optimization process utilize Minitab 17 software with box band design with one replication. The key factor is pH from 7 to 12, the silver nitrate mass from 0.013 to 0.13 gram, and the irradiation time from 15 to 240 minutes. The controlled variable is finger root, extract mass 0.2 gram. The response is absorbance at wavelength of 430 nanometer. The optimized silver nanoparticle solution then analyzed with particle size analyzer. The result, this is the box band optimization table. We use one replication for this response, and thus we have 15 experiments. There are spectrum of silver nanoparticle that came from box band experiment from first standard to 15 standard of. The formation of silver nanoparticle is characterized by absorbance peaks at wavelength of 400 to 450 nanometer. This is the surface plot. There are this is the first plot is the plot of absorbance versus silver nitrate and irradiation time. This plot indicate the max absorbance result is between 100 to 200 minutes on irradiation time and 0.12 to 0.13 gram on silver nitrate mass when the pH is held on 9.5. The second plot is the plot absorbance versus silver nitrate mass and pH. This plot indicate that max absorbance result is between pH 10 to 12 and silver nitrate mass between 0.08 to 0.12 gram. When the irradiation time is held in 127.5 minutes. The third plot is plot absorbance versus irradiation time and pH. This plot indicate that max absorbance result is between pH 10 to 12 and irradiation time between 100 to 200 minutes. When the silver nitrate mass is held on 0.715 gram. And then from the Minitab software, we get the regression equation as shown in the slide. The optimization plot from Minitab software indicated the optimum condition. The optimum pH is 11.49. The optimum silver nitrate mass is 0.13 gram, and the optimum irradiation time is 178 minutes. The prediction of absorbance in optimum condition is 2.2646, and then this is the spectrum of silver nanoparticle in the optimum condition mentioned before. The actual absorbance of silver nanoparticle in 430 nanometer is 2.229. The optimized silver nanoparticle was characterized with particle size analyzer to find out the size and zeta potential. The size of silver nanoparticle range from 93 to 270 nanometer, and the average size is 150 1.6 nanometer with the polydispersity index in 0.17. The zeta potential of synthesized silver nanoparticle is minus 57.6 millivolt. This is indicated that the silver nanoparticle synthesized by finger root extract is very stable. The conclusion is finger root rhizome extract can be potential reducing and stabilizing agent in silver nanoparticle synthesis, and the absorbance optimization via box band method used for determining most yielded silver nanoparticle synthesis by using finger root extract as a beta dosing agent. Okay, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mas Wisnu. We dikdo for your very nice presentation. It is about an approach to synthesize silver nanoparticle, right? If I'm not mistaken, it is intended for antioxidant also, right? The nanoparticle. Even though in this work, it is only reporting the synthesis process. Okay, ladies and gentlemen, any question for Mas Wisnu? Halo, Bapak Ibu, ada pertanyaan? Okay, Mas Wisnu Widikdo, you did synthesize the silver nanoparticle by using the finger root as a reductor agent, right? Hello, Mas Wisnu, are you there? Hello, Mas Wisnu. Okay, I think.
Sorry, my signal is so bad here. Can I don't hear the question? Can may you repeat the question? Sir,
okay,
I'm very sorry.
Okay, since you use the finger root as a reductor agent for synthesizing the silver nanoparticle, right? And the results show that that the nanoparticle was successfully synthesized by this approach, right? My question is, it is when you measure the result, the nanoparticle using particle size analyzer, is the finger root extract still there in the sample, or you separate it from the sample?
I don't separate it. I don't separate it because the PSA is used sorry, can I answer in Indonesian?
Ya. Yes lah.
Saya tidak menseparasinya atau tidak mensentrifusnya karena pertama di PSA itu menggunakan prinsip dynamic light scattering, jadi untuk PSA-nya tidak dikeringkan dulu atau tidak dilifofilisasi dulu dengan freeze drying, jadi saya langsung melakukan analisis PSA-nya, Pak. Jadi tidak diseparasi dulu.
Oke, baik. Ini tadi kan aplikasinya untuk apa ke depannya, Mas?
Kedepannya kemungkinan untuk antibakteri dan sebenarnya untuk kosmetik sih, Pak.
Ya, karena nanti kan biasanya kalau reduktor itu dia nanti berperan sebagai capping agent juga, ya kan? Nah, nanti jadi sebenarnya yang jadi pertimbangan itu nanti apakah si finger root-nya juga punya karakteristik antibakteri, ya? Atau tadi apa?
Toko kosmetik, Pak.
Ya, untuk antioksidan kali ya, kosmetik ya, atau apalah gitu ya. Nah, ini nanti kan jadi pertimbangannya di situ sebetulnya, ya. Itu saja sih, ya. Oke, terima kasih Mas Wisnu atas presentasinya. Oke, Bapak Ibu, we have to move to our next presenter, which is Mbak Siva Aulia Mumpuni, ya. Ini should be always Mumpuni, ya. The title of her presentation is Microlife Assisted Synthesis of Coumarin 3 Carboxylate through Cnofenagel Condensation with Aluminum Chloride Catalyst. Okay, Mas Muhammad, please play the video presentation, and Mbak Siva, please be ready after your video. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all the lecturer and reviewer, and good afternoon to the audiences. I would like to introduce myself first. My name is Siva Aulia Mumpuni from Chemistry Universitas Negeri Jakarta, and I am here to explain about microwave assisted synthesis of coumarin tricarboxylate through Novanago condensation with aluminum chloride catalyst. Next. So, what is coumarin? Coumarin is a group of phenylpropanoate compounds that have a 6-circle-like tone ring and have a 2H1 benzopyran 2 on nucleus with the molecular formula C9H5O2. Found as a natural secondary metabolites in plants, bacteria, fungi, essential oil, and can be chemically synthesized. And this study aims to do coumarin synthesis with microwave-assisted synthesis method via Novanago condensation. Here we reacted to hydroxybenzaldehyde and diethyl malonate with aluminum chloride and diethylamine as a catalyst, so the product will be ethyl coumarin tricarboxylate. We use Novanago condensation with microwave irradiation method. The Novanago condensation usually use Lewis acid or weak base as a catalyst. For this study, we use aluminum chloride for the Lewis acid and diethylamine for the weak base. Next. There are some reactions that can use the microwave irradiation method, such as hydration of materials, isomerization, condensation, multi-component reaction, cyclization, coupling, and reduction reaction. And this method also have some strengths, such as shorter time, lower energy, and higher yield. On the right side, we can see the differences between microwave heating and conventional heating. The conventional heating do the heating by convection currents, and it can make the vessel wall very hot before heating the sample. But the microwave heating go through the vessel wall and heat the sample directly on a molecular basis. Next. The method is first, we reacted to hydroxybenzaldehyde with diethyl malonate. Next, the coumarin product is purified with recrystallization, so it produces the pure compound. And the last, we do the characterization with UV-vis spectral photometry, and also we do the melting point test. Next. And here is the procedure detail. 2-hydroxybenzaldehyde with diethyl malonate added into 50 milliliter beker glass, add aluminum chloride catalyst, and stir in a room temperature. The mixture added into 50 milliliter crucible porcelain and put it in the microwave for 10 minutes in 100 watt. And the reaction monitored with TLC with ethyl acetate and hexane as the L1. After that, the mixture added with hot ethanol and stir until homogeneous. And it filtered with filter paper. And after that, we wait for 24 until 48 hours to form a crystal from filtrate. And the crystal is characterized with UV-vis spectrophotometry, and we do also the melting point test. Next. So for the result and discussion, I will explain a little bit about the mechanism. First, the carbon on the aldehyde group attached by the active methylene group. Deprotonation of the activated methylene by the base or the ethylamine to give a carbanion. And then nucleophilic attack on the carbanion belonging to the carbonyl of the aldehyde. So the final result is ethyl coumarin tricarboxylate. Next. So here is the composition of the reaction. Entry 1, 20 millimole of 2-hydroxybenzaldehyde and 24 millimole of diethyl malonate mixed with 2 millimole of aluminum chloride, and the duration for the reaction in the microwave is 10 minutes. The yield is 12.98%. Entry 2, 50 millimole of 2-hydroxybenzaldehyde and 60 millimole of diethyl malonate mixed with 2.5 millimole of aluminum chloride. And the duration for the reaction in the microwave is 15 minutes. The yield is 6.17%. And the last, entry 3, 50 millimole of 2-hydroxybenzaldehyde and 60 millimole of diethyl malonate mixed with 3.75 millimole of aluminum chloride and also 10 millimole of diethylamine. And duration for the reaction in the microwave is 10 minutes. The yield is 31.56%. And the results show that diethylamine systems produce more product. Next. Next is the sample tested for the melting point. And the literature showed that ethyl coumarin tricarboxylate has melting point at 92 to 94 degrees Celsius. But when all of the sample tested at 90 to 97 degrees Celsius, the sample are not melting. The next is the UV spectral photometry. Sample 1 has absorbance value 2.218 at maximum wavelength 371 nanometer. Sample 2 has absorbance value 2.252 at maximum wavelength 369.5 nanometer. Sample 3 has absorbance value 2.277 and at maximum wavelength 370.5 nanometer. But it's different from the literature, which is for ethyl coumarin tricarboxylate has absorbance value around 0.64 at maximum wavelength 292 nanometer. Next. So the conclusion for this study is reaction with 3.75 millimole aluminum chloride and 10 millimole diethylamine has the highest yield, and the synthesized product is still not pure and it still have the impurities. Next. That's all
Okay,
for me. Thank you for your attention.
Okay, thank you, Mbak Siva Aulia Mumpuni, for your presentation.
Yeah.
Okay, ladies and gentlemen, any question for our presenter? Okay, Mbak Siva, you synthesize the coumarin tricarboxylate, right?
Yes.
So, but in your result and in your conclusions, it's mean that it is not successfully synthesized, right? I just want to further confirm whether it is not successful synthesized or it is actually successfully synthesized, but you cannot have it in the pure basis, which is correct.
Okay. So when I do the synthesize, it would be a crystal form, but I get it like powder form. So I think the powder form it's not pure yet, like a crystal form.
It's okay, but as I know, to confirm that we successfully synthesize a certain compound, so we have to do many things to make sure that it is we get the compound, right? In this case, you only use the UV visible and also melting point analysis, right?
Yes.
Okay, so I hope you can do the the others characterization to make sure that
Yeah.
about the result of your work, right?
Yeah.
Okay, Mas Dandi, you have question, please? Mas Dandi Akbar? Okay.
I would like to ask in the result and discussion section, there is a table containing the composition and yield result. Then what makes the yield different from one and another?
Oh.
Is the question.
Okay. Okay, the yield is different is if we compare the entry 1 and entry 2, the entry 2 has the lower yield than the entry 1, which is the entry 2 has the 6.17% and the entry 1 is 12.98%. It's because entry 2 use less catalyst than the entry 1. And also the reaction time of the entry 2 is faster than it's longer than the entry 1. And then if we see the entry 3, the yield is 31.56%. It's because the entry 3 use less catalyst than the entry 1, but the entry 3 use the diethylamine also in its reaction. So from there, we know that the use of catalyst and the reaction time is affect the yield. So the optimum mass of catalyst and optimum reaction time should be used to make a higher yield. The use of catalyst cannot be so too little and can be too much. And the reaction time cannot be too fast and cannot be too long too. It's the answer.
Okay. Okay, my last question, Mbak Siva. Are you going to conduct some other characterization for the result to make sure what you have? Okay. What kind
the
of
NMR?
NMR. Okay. Okay, good. Okay, thank you, Mbak Siva Aulia Mumpuni for the discussion. And we are going to our next presenter, which is Mbak Nabila Seflini. Okay, I think it should be from the same group. The title of the paper, Synthesis of chalcone derivative from vanillin using microwave irradiation method. Mbak Nabila, are you there?
Yes, sir.
Okay, okay. Please play the video, Mas Muhammad.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Nabila Seflini. Today I want to present about synthesis of chalcone derivative from vanillin and acetophenone using microwave irradiation method. First is introduction. Chalcone contains two aromatic rings, A and B, and unsaturated carbon atoms in alpha and beta position. In laboratory synthesis, chalcone can be prepared using the Clayson-Smith reaction by reacting acetophenone or its derivative with benzaldehyde or its derivative using strong base such as sodium hydroxide, potassium hydroxide, barium hydroxide, or sodium hydride catalyst in a polar solvent. While acid catalysts commonly include hydrochloric acid, aluminum chloride, titanium tetrachloride, and ruthenium chloride. Microwave irradiation method is a chemical reaction method that uses microwave radiation to accelerate organic reaction. The microwave method can be used as an effort to realize the principle of green chemistry because with a short reaction time, the use of energy becomes efficient. The use of this method is very accordance with the principle of green chemistry because this method only requires a little time, easy processing, and cleaner products. And next is method. Synthesis of 4-hydroxy-3-methoxychalcones. 5 millimole vanillin and 5 millimole of acetophenone was dissolved with 7.5 milliliter of absolute ethanol. Add 10 milliliters of potassium hydroxide catalyst. And next, irradiate by microwave at 180 watts for 5 minutes. The reaction step was observed by TLC test. After the reaction was complete, 15 milliliters of cold distilled water was added to the mixture, and the pH of the mixture was neutralized with hydrochloric acid. The mixture is left for 24 hours in the refrigerator. The precipitate that formed was then recrystallized with hot ethanol and then left at room temperature. The recrystallized results were filtered using a Bachner funnel and then allowed to dry. The purity of the compound is determined by melting point test. Pure compounds were characterized by UV spectroscopic analysis. Okay, next is result and discussion. Chalcone compounds were synthesized through the Clayson-Smith reaction from acetophenone and vanillin compounds. The reaction was carried out using microwave irradiation with the addition of potassium hydroxide as a catalyst. The resulting chalcone compound is crystal and yellow in color with a height of 1.24 gram. A yield of chalcone is 97.64% and a melting point of 80 to 84 degrees Celsius. Analysis with UV spectroscopy showed the presence of 3 peaks, which are characteristic of chalcone compounds, namely in the wavelength region of 206 nanometers, the absorbance 0.563, a wavelength of 235 nanometers, absorbance in 0.951, and wavelength of 360 nanometers, absorbance in 0.591. And chalcone can be easily synthesized and functionalized to form derivatives having with the wide max range, such as 280 to 365 nanometers, and relatively high molar absorptivity. The final is conclusion. Chalcone was successfully synthesized from vanillin with acetophenone by microwave irradiation method with potassium chloride catalyst. Pure chalcone was obtained with a yield of 97.64% and melting point 80 to 84 degrees Celsius. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you, Mbak Nabila Seflini. Okay, any question for Mbak Nabila? Ladies and gentlemen, ada pertanyaan yang ingin disampaikan? Okay, Dandi, please, your question.
Yeah, thank you. I have a question. Can you explain why you using base as a catalyst? Thank you.
Okay, thank you for the question. Mbak Nabila, please, you respond to Mas Dandi question.
Okay, why use base catalyst? Based on previous research, base catalysts are more effective and can produce higher yields. That's it.
Okay, thank you. Mbak Nabila, any question from the others? Okay, Mbak Nabila, is it your ongoing work or have you finished the research?
Yeah. Can I use Indonesian?
Ya boleh.
tinggal satu karakteristik lagi Pak, apa namanya, NMR.
Yeah. Okay. Because I don't think that you can conclude your work by only using UV visible spectral photometer data, right?
Yes.
So you have to do the other characterization. Even proton NMR, I think it won't be enough. Okay.
Okay.
You have to conduct the other. So you can discuss it with your team, right? To make it to have a good result from your work. Okay. Have you success with your work, Manabila? Thank you for your presentation.
Okay,
And Bapak Ibu, let's move to our next presenter, Mas Pandu Rizky Triananda. Okay, Mas Pandu, are you there? Yeah, okay. Mas Muhammad, please play the video.
Good day, everyone. I'm Pandu Rizky Triananda from Chemistry Department, Faculty of Mathematics and Natural Sciences, Universitas Negeri Jakarta. Today, allow me to present my research entitled Synthesis of Chalcone Derivative from Vanillin using Microwave Irradiation Method. So, chalcone compound is one of derivatives of flavonoid which has a structure in the form of two conjugated phenyl rings connected by alpha-beta unsaturated ketone bonds. This compound was reported to have many bioactivities such as antibacterial, anti-cancer, antioxidant, and anti-inflammatory. The broad use of chalcone continuously supports research on chalcone synthesis and its bioactivity. Vanillin is a phenolic compound derived from benzene with a methoxy functional group in the ortho position and an aldehyde group in the para position. According to the researchers, the most easily reacted functional group in vanillin is the aldehyde group. This can be used to form a new compound through aldol condensation reaction. Therefore, vanillin can be used as an aromatic aldehyde derivative in the synthesis of chalcone. And one of many ways to synthesize a chalcone is through Clayson-Smith condensation reaction. A Clayson-Smith reaction is a reaction involving the reactivity of the carbonyl group towards nucleophilic attack. It is a condensation reaction of an aromatic aldehyde with an aromatic ketone under both acidic and basic conditions. In the Clayson-Smith reaction, the ketone compound formed is usually not found as the final product. This compound will undergo a dehydration reaction. In addition, the reason Clayson-Smith was used in this research is because the reaction is simple, the raw materials are easy to obtain and environmentally friendly. In this study, we synthesized a chalcone using a base catalyst. Because it was reported that the use of an alkaline catalyst resulted in a higher yield. This can be explained in the picture of the mechanism beside. In the mechanism, the hydroxide ion will attack the hydrogen alpha of the ketone compounds and form a resonant enolate anion. Then the nucleophilic compound by the enolate anion that resonates will attack the C-carbonyl of the aldehyde compound. And then the product is undergo a dehydration process to produce the unsaturated compound, which is the chalcone. Microwave irradiation method is a chemical reaction method that uses microwave radiation to accelerate organic reactions. The microwave method can be used as an effort to realize the principles of green chemistry, because with a short reaction time, the use of energy becomes efficient. The use of this method is very in accordance with the principles of green chemistry because this method only requires a little time, easy processing, and a cleaner product. In addition, synthesize Synthesis using microwaves can also reduce unwanted reactions, and it can prevent the formation of byproduct and produce a purer final product with higher reproducibility and avoid heat loss to the environment, and can also reduce the equipment cost or the production cost. The steps to synthesize the chalcone derivative that I do in this study are firstly 5 millimole of vanillin and 5 millimole of 4-hydroxyacetophenone was dissolved with 7.5 milliliter of absolute ethanol in a beaker glass. And then 10 milliliter of potassium hydroxide was added into the mixture, and after that the mixture was irradiated with microwave at 300 watts for 4 minutes. The reaction steps were observed by TLC test for every 1 minute. After the reaction was completed, the mixture was diluted with 15 milliliter of cold distilled water and then neutralized with chloric acid. And then the mixture was left for 24 hours in the refrigerator, and then the precipitate that formed is recrystallized with hot ethanol. The recrystallized product then were filtered using a Bachner funnel and then allowed to dry. The purity of the compound is determined by a melting point test, and also a thin layer chromatography test. The pure compounds were characterized by UV spectroscopic analysis. The result of my research is this is the result of my research. This table shows you the temperatures maintained during the reaction. The reaction mixture temperatures are maintained at 65 degrees Celsius until 75 degrees Celsius. This is because optimum reaction conditions occur when the reaction temperature reaches 70 degrees Celsius. When the temperature is raised, the solid phenoxide formed at the beginning of the reaction dissolves well, and the Clayson-Smith reaction will take place. In addition, increasing temperature also influences the equilibrium direction of product formation, especially at the reversible intermediate formation and the dehydration steps. This is consistent with Le Chatelier's principle. The product in this study appeared as yellow crystalline with a weight of 1.08 gram and a yield of 80.65%, with a melting point of 86 to 90 degrees Celsius, which indicate the target product was formed. The TLC test also showed only a single spot on reaction product, which also indicate the pure chalcone product was obtained. And the UV spectrum of the synthesized chalcone showed a maximum absorption peak at 270 nanometers and 358 nanometers. According to Wijayanti in her research in 2020, the UV spectrum of chalcones consists of two essential absorption bands. We can call it the band 1 and band 2 as major and minor bands. Band 1 of chalcone usually appears at 220 until 270 nanometers, while band 2 appears at 340 to 360 nanometers. The absorption peak at 270 nanometers indicates the presence of a benzoyl system, while the absorption peak at the 358 nanometers indicates the presence of a cinnamoyl system in the product that we have. Thus, the 3,4-hydroxy-3-methoxyphenyl 1,4-hydroxyphenyl 2-propan 1-none is successfully synthesized. The conclusion of my study is chalcone derivative was successfully synthesized from vanillin and 4-hydroxyacetophenone by microwave irradiation method. Pure chalcone was obtained with a yield of 80.65% with a melting point of 86 to 90 degrees Celsius, and the UV spectrum of the products showed the presence of cinnamon system at 370 nanometers and benzoyl system at the cinnamon system is at 200 and 358 nanometers and benzoyl system at 270 nanometers. And to fully knowing what's the usage of this product, so further testing such as bioactivity testing is required to determine the application of the synthesized product on medical role. That's all I can say for my presentation. Thanks for your all kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you, Mas Pandu, for your nice presentation. Okay, ladies and gentlemen, any question for our presenter?
Yeah, may I ask question?
Okay, please.
Thank you, Dr. Setiabudi, for the time. I want to ask question to Pandu that it was mentioned in your presentation that you are using electrical power of 300 watts, yeah? Why did you use that and not other value or of electrical power? Thank you.
Okay, thank you for the question. Allow me to answer the question. So, why did I use the electrical power of 300 watts? Actually, in my research, I used 3 electrical power, which is 100 watts, 180 watts, and 300 watts. But the other two, the product of the 100 watts and 180 watts is not formed. So I can use it in this paper. Also, if I compare with the literature, the 300 watts is a better method to synthesize a chalcone. That's it for my answer.
Okay. Okay. Any other question, Mbak Ismaya?
No, it's enough.
Okay, thank you, Mbak Ismaya, for question, and also Mas Pandu for your presentation. Now we have to move to the next presenter, which is Mbak Rehan Siva. Mbak Rehan Siva, are you there? Mbak Rehan? Mbak Rehan? Okay. Mbak Rehan, are you there, Mbak Rehan?
Yes, I am here.
Okay. Okay, it's okay. Please, if it is possible, please open your camera, and Mas Muhammad, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I would like to quickly introduce myself. I am Rehan Shifa, an undergraduate student from Chemistry Department, Faculty of Mathematics and Science, Universitas Negeri Jakarta. Today, I will present my findings on synthesis 3-acetylcoumarin via noble condensation under microwave irradiation. Today, I will be covering these 4 key points, which is a brief introduction about coumarin and the noble condensation, the method that I used to synthesize 3-acetylcoumarin, the result and discussion for this experiment, and last but not least is the conclusion. Okay. Coumarin has chemical structure composes alpha pyrrole rings and fused benzene with 6 available sites for substitution. And due to this reason, more than 1,300 coumarins have been identified from natural sources. Coumarin is a therapeutic agent found as naturally occurring secondary metabolite in plants, bacteria, fungi, essential oil, and can also be chemically synthesized. Coumarin are significantly well known as they exhibit valuable biological properties or their bioactivities, such as antioxidant, antifungi, anti-inflammatory, antibacterial, anticoagulant, anti-tumor, antimicrobial, and enzymatic inhibitory activities, and so many more. And beside their biological activities, most compounds show many valuable applications in pharmaceutical, fragrance, insecticides, and dyes. There are various synthetic pathways to actually synthesize coumarin derivatives, such as protein condensation, Nova-Nagel condensation, Teichmann reaction, and metal catalyzed cyclization. And for this experiment, we're going to be a bit more focused on Nova-Nagel condensation, as we're going to use 2-hydroxybenzaldehyde as the aldehyde, ethyl acetoacetate as an activated methylene, with the ethylamine as a catalyst, with the byproduct is 3-acetylcoumarin. From my literature surveying, there are not many researchers using the ethylamine as a catalyst, and it piques my interest to use the ethylamine to synthesize 3-acetylcoumarin in this experiment. Like I said, we're going to be a little bit more focused about Nova-Nagel condensation because we're going to use aldehyde and activated methylene with amine base as our basic reaction. Nova-Nagel condensation is one of the most widely used methods to synthesize coumarin derivative as they are fast and practical. Nova-Nagel condensation is a nucleophilic addition of an activated methylene compound to an aldehyde or ketone using an active hydrogen compound in the presence of basic catalyst. We can see from the picture, from the right picture, this is the basic Nova-Nagel reaction with ketone and activated methylene. In the presence of amine base, undergoes dehydration to actually, and the byproduct is alpha-beta unsaturated compound. On the left picture, Pawar, Wach, and Lally in 2016, they successfully synthesized cinnamic acid with Nova-Nagel condensation, undergoes Nova-Nagel condensation pathways with their aldehyde is benzaldehyde, and malonic acid as their activated methylene, using TEA as their catalyst and piperidine as their amine base to synthesize the cinnamic acid derivatives. Next, synthesis of 3-acetylcoumarin was synthesized from 2-hydroxybenzaldehyde and ethyl acetoacetate using the ethylamine as a catalyst. This mixture then was irradiated under microwave irradiation, and the reaction progress was monitored by TLC or thin layer chromatography, and then the product was isolated by filtration, and then we recrystallized it with hot ethanol and dried in the air. The mixture then was tested for purity by thin layer chromatography and melting point test, followed by structural elucidation using UV visible spectral photometry. Okay, in this experiment, 3-acetylcoumarin has been successfully synthesized via Nova-Nagel condensation under microwave irradiation. And there are two possible mechanisms for this reaction between the aldehyde and activated methylene in the presence of the ethylamine. The first proposal includes forming an imine or iminium salt from the amine with benzaldehyde, which is then followed by a reaction with the enolate from activated methylene and elimination of the amine and intramolecular ring closure. But for the second option, the carbanion from amine,
from amine deprotonation, of the activated methylene attack the carbonyl group. Attack the carbonyl group in aromatic aldehyde to obtain the intermediate. The intermediate then undergoes proton transfer, ring closure via cell substitution, and then dehydration. The optimal condition for the reaction was established by reacting ratio 1.2 with 1 substrate, which is 1.2 of 2-hydroxybenzaldehyde and 1 molar ratio of ethyl acetoacetate with 30% of the ethylamine for 60 seconds, for 70 seconds, and for 80 seconds under solvent-free condition and microwave irradiation. And the variety of reaction time was observed and had a considerable impact on the yields. And from what we've known, raising the irradiation time to 80 seconds reduced the yield further. This could possibly be happen because at a longer reaction time, the formation of byproducts such as chromone and self-condensation of ethyl acetoacetate, and also the isomerization and cleavage of triacetylcoumarin could possibly be the result of lower yield in a longer reaction time. That's why the 60-second time was the best time to conduct this reaction. Next, the mixture was tested for purity by thin layer chromatography and melting point. In the thin layer chromatography test, N-hexane and ethyl acetate was used as eluent. When the TLC part, when the thin layer chromatography plate shine by the UV lamp, there is one dot, which means the sample was pure and there is no contaminant in it. The melting point was also showed that melting point of the sample was similar to a triacetylcoumarin melting point from the literature, which is around 119 to 121 degrees Celsius. The structural elucidation by UV spectra also show the maximum length, the maximum wavelength, confirming typical peaks of coumarin, which is lactone group peaks, cinnamoyl group peaks, and benzoyl group peaks. The fruit product that we had after recrystallization and filtration is a pale yellow solid, and when we weighted, it was about 0.0445 gram, and the yield is 23%. Okay, that brings us to the end of the presentation. I like to summarize by saying triacetylcoumarin was successfully synthesized. It was confirmed by thin layer chromatography, melting point test, and UV spectrophotometry. The yield obtained is 23%, and from this result, it can be concluded the optimum reaction time to synthesize triacetylcoumarin was 60 seconds. Thank you for your attention. Have a good day, everyone.
Okay. Thank you, Mbak Rehan, for your nice presentation. Any question for Mbak Rehan? Yes, Jefferson.
Thank you for the opportunity. My name is Declan from Universitas Negeri Jakarta. I want to ask to Rehan Shiva. And before, thank you for your good presentation. You said before there are many methods that we can use to synthesize the coumarin. So my question is why you choose the irradiation microwave than the others method? Thank you.
Okay, thank you for the question, Declan. I choose to use microwave irradiation to assess the Nobunaga condensation for this reaction because the microwave irradiation allow us to have reactions in solvent-free condition, and it takes a shorter reaction time to synthesize triacetylcoumarin. Usually it will take 2 to 16 hours, but with the help of irradiation, microwave irradiation, it only take 60 seconds to 10 minutes. That's why I chose microwave radiation to assess this reaction. Thank you.
Thank you.
Okay, thank you for the question, Declan and Rehan Sifa for the very nice presentation. Okay, I think due to the time limitation, we have to move to our next presenter, which is Mas Dandi Akbar Juliansa. Okay, Mas Dandi, are you there?
Yes, I'm
Okay.
here.
Okay. Are you conduct presentation directly or by video?
By video.
Okay, Mas Muhammad, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Dandi Akbar Juliansyah. I'm from Universitas Negeri Jakarta. I would like to present our result research with the title GRXV gene as a potential target for the development of Chronobacter Sakazaki detection method in infant formula milk using PCR. This our team and our partners who contribute to our research. And also this research is funded by PDUPT scheme. According to data from the World Health Organization, for each year, 1 of 10 persons in the world become sick after eating contaminated food, and it's estimated that every year 600 million people in the world experience food poisoning. This causes more than 420,000 deaths. As we know, the Chronobacter Sakazaki is the one of bacteria that can contaminate food, and this bacteria is dangerous, especially for infants and neonates. In the United States, there are an average of 180 cases of Chronobacter Sakazaki contamination each year. So the presence of Chronobacter Sakazaki in food has been widely reported, especially in infant formula milk. Infant formula milk can be a good growth medium for this bacteria because there are sufficient time, right temperature, and most importantly, nutrients. The first step of Chronobacter in the invasion stage of the digestive system is the ability of the bacteria to adhere to the surface layer of intestine. Chronobacter sakazaki is a bacterium that can penetrate the blood-brain barrier, and this causes necrotizing enterocolitis, meningitis, and sepsis in neonates or infants. Chronobacter sakazaki bacteria can be detected by PCR method. Basically, PCR method is a molecular technique to amplify DNA to thousand or million of copies of the target DNA sequence. There are 3 stages in PCR: denaturation, annealing, and extension process. It is necessary to identify the optimal annealing temperature, because if the annealing temperature is too low, non-specific amplification can happen. And if the annealing temperature is too high, it can cause the primer to be damaged. So it is necessary to optimize the annealing temperature so that the primer can attach perfectly to the target DNA template. Because our goal is to determine the optimal annealing temperature, then we use the gradient PCR to determine the optimum annealing temperature. We move to methodology. The first step, we designed the primer. Then we did a bacterial culture. After that, Chronobacter sakazaki DNA was isolated. Then, to get the optimum annealing temperature, we did a gradient PCR test. After that, we characterized the PCR result by agar-scale electrophoresis. The first step was in silico analysis. So we have studied the genome of Chronobacter based on the data contained in the gene bank. To find the genome data of Corynebacter sakazaki, we have accessed the database through the NCBI website. Based on this in silico analysis, we found that the total genome size of the bacteria Corynebacter sakazaki was 4.3 megabases. Then from this database, we have also selected one gene from hundreds of thousands or even millions of genes for the bacteria Corynebacter sakazaki. We have selected the GRXB gene as the target for the detection by PCR. So GRXB or glutaredoxin B is a gene that contributes to stress response of environmental condition of Corynebacter sakazaki facing acid stress and plays a role in biofilm formation. And then after we selected the GRXB gene from the Corynebacter sakazaki genome, we finally designed the primer. This primer pair can amplify 151 base pair. From this result, we can conclude that the GRXB gene specific primer has been successfully designed and synthesized as a target for the detection of Corynebacter sakazaki. After that, we did the bacterial culture. We have run the bacteria Corynebacter sakazaki in suitable media so that its growth is optimal and the genome can be taken as a template. Corynebacter sakazaki mixed was resuspended with hydrating liquid and planted into tryptic soy agar or TSA media using the strict method. Then it was incubated for 24 hours at 37 degrees Celsius. After that, the single yellow colonies formed were taken using a sterile loop wire and inoculated in 10 milliliter of tryptic soy broth media. Then the sample incubated for 24 hours at 37 degrees Celsius using the shaking incubator at 150 RPM. And the results show that the formation of turbidity in the broth medium indicated that the bacteria were growing well. And to make sure the bacteria grow well, we have checked the OD600 value, and the result of the OD600 value obtained is 1.86, which indicated that the bacteria has grown. The next step was DNA isolation. DNA isolation to take the genome of Corynebacter sakazaki as a template for PCR. And to make sure that the isolation was successful, we did the characterization by agarose gel electrophoresis and with nanodrop spectrophotometer. We can see the result of electrophoresis. If we see the green lines, we call them DNA bands. The result show that the DNA isolated at wells 2, 3, 4, and 5. And the result is above 10,000 base pair. So we can conclude that the isolation of Corynebacter sakazaki was successful. And the purity of the isolated DNA was measured by using nanodrop spectrophotometer. And the result of purity and concentration are available in the table. The next step is to amplify by gradient PCR. Gradient PCR assay step conditions are available in the table. So gel electrophoresis result show that the design primer successfully amplified the GRXB gene with an amplicon length of 151 base pair. It was also found the optimum annealing temperature based on the brightness, and only a single band appeared. Optimum annealing temperature of the GRXB primer pair obtained at range of 57 to 62 degrees Celsius. We move to conclusion. First conclusion is a pair of GRXB gene primers was able to amplify Chronobacter sakazaki gene fragments to produce 151 base pair amplicon length. And then the optimal annealing temperature for GRXB primer pairs at the range of 57 to 62 degrees Celsius. Furthermore, the GRXB primer design and optimum temperatures obtained will be used for the development of a sensitive and specific rapid detection method of Chronobacter sakazaki in infant formula milk using real-time PCR.
Okay. I think the video has finished. Okay. Okay. Thank you, Mas Dandi, for your presentation. And now we move on to the question and answer session. So, Mbak Siva, okay. Do you have question for Mas Dandi?
Yeah.
Okay.
Okay, thank you, Pak Budi. I would like to ask to Dandi, as you have explained before that you use triptych soy agar as the media for the bacterial culture. So the question is, why did you choose that type of media for the bacterial culture? Thank you.
Okay, thank you for the question.
Dandi, please. Okay. Okay.
Okay. So this is based on the journal or the reference that I have read, and that's informed the bacteria, the Chronobacter sakazaki bacteria can grow optimally on the TSA media. So the Chronobacter sakazaki bacteria grow at the temperature between 6 to 47 degrees Celsius and is capable of producing yellow pigment on the TSA media. So TSA media is usually used for culture storage, cell enumeration, or pure culture isolation. And for the general culture, so that's the answer.
Okay, thank you, Dandi.
Okay, thank you. Any other question? Bapak Ibu, ada pertanyaan lagi? Okay. If no, we are going to move to our next presenter.
I think there's one question from Nabila.
Okay.
Yeah.
Okay. Please, Nabila. What is the question for Mas Dandi?
Okay, I would like to ask, can you explain why did you use PCR as a detection method in this research? Is there any other method that can be used? Thank you.
Okay, I would like to answer question from Nabila. So why I use PCR as a detection method? So the PCR is considered as the new gold standard for detecting various bacteria at the molecular level, and it has been widely developed as a routine diagnostic application in clinical microbiology laboratories. And this PCR technique is be able to perform diagnostic tests on bacteria with good sensitivity and specificity and save more time than the other diagnostic tests. So in the other words, the PCR method can detect a bacteria with and then is there any other method that can be used? Yeah. Yes, there's the culturing method. So the culturing method is the one of the conventional method that used to detect pathogenic bacteria in food product. So, however, using this method takes a relatively long time and is not specific for detecting pathogenic bacteria. So I thought the PCR method is way better than the culturing method. So that's the answer.
Okay. Okay. Thank you for your answer, Mas Dandy, and for the question for Nabila, right? Okay. Because the time limitation, I think we now have to move to our next presenter, which is Mas Jefferson Linford Declant, who will present his paper entitled "The Potential of NI1 Gene as a Target Detection for Listables Samples using Polymerase Chain Reaction Method." Okay. Are you going to deliver your presentation directly or by video?
By video.
Okay, Mas Muhammad, please play the video.
Hello everyone, my name is Jefferson Linford Declan from Salmonella Team, Center of Excellence, Pathogenic Bacteria Detection, Universitas Negeri Jakarta. Today, I want to present my research about the potential of ENLA gene as the target detection for Listeria monocytogenes in vegetable sample using polymerase chain reaction method. Before I start, I want to thank you for the Lembaga Penelitian dan Pengabdian pada Masyarakat LPPM Universitas Negeri Jakarta for founded this research in scheme of Pusat Unggulan IPTEX 2022. According to the World Health Organization around the world, 600 million cases of foodborne disease happen every year. This led to the 400 to 20,000 deaths caused by this disease. Listeria monocytogenes is the one of the bacteria that the agent of the foodborne disease. Listeria monocytogenes is a gram-positive, bacillician, and an anaerobic facultative pathogenic bacteria that can survive in extreme conditions such as acid, salt, low, and also for the high temperature. This bacteria can be found in many types of food, including beef, chicken, mushroom, milk, egg, and the vegetables, especially the fresh vegetables. Listeria monocytogenes infect humans through the contaminated food, and after we eat the food, the bacteria can infiltrate into the host cell and move to the bloodstream and circulate around the body. The incubation period of this bacteria is around 2 until 70 days and lead into the listeriosis illness. Listeriosis have the wide range spectrum of symptoms such as fever, headaches, diarrhea, abdominal aches, nausea for the non-invasive listeriosis in the healthy person. But for the high-risk people, it can lead to the meningitis, fever, miscarriage, septicemia, myalgia, with the death rate until 30%. And it called listeriosis invasive listeriosis. For the dose of infection for this bacteria is 10 million until 100 million CFU in the healthy person, but for the high-risk person, the bacteria only need 0.1 million until 10 million CFU for the high-risk person. This is very dangerous, and it means that we need to develop a detection method to detect Listeria monocytogenes in the food sample. One of the detection methods that we can use is the polymerase chain reaction. PCR is the molecular technique to exponentially amplify the DNA to the 1,000 or to the million copy of the target DNA sequence. We can see at the right of this slide. This is the step, the three major steps of the PCR. The first is denaturation, in when we denaturating the double strain DNA to the single strain DNA with a heating. After that, the annealing temperature. The annealing step. The annealing step is when the primer attached into the specific sequence of the template. After that, the extension. In the extension, when the primer gets extended with the help of the Taq polymerase enzyme and the free DNTES. In the PCR process, the annealing step is an important step because the primer attached in the sequence that we want. So we need to optimizing the annealing temperature for the more efficient and the more specific PCR process. This is the methodology that we use for this research. We divide it into the 5 major steps. First is the primer design and the synthesis of the primer. In this step, we analyze both in silico or the literature analysis from the gene until the primer that we get. Second, we grow the bacteria on the solid and the liquid media. After that, we do the isolation process and get the DNA genome as the template for the PCR process. Then we do the PCR gradient process to optimizing the annealing temperature of the primer, and we check the result of electrophoresis agarose. And this is the gene that we use as a target for the PCR. Based on our literature and the in silico research, ENLA gene was used because this gene exists in the most of the Listeria monocytogenes strain, and for the specificity, this is very specific for only for Listeria monocytogenes. This gene produces the internal A protein that acts as a mediator for the bacteria to infiltrate the cell. And this gene has size of 2043 base pair for the Listeria monocytogenes ITCC 13932. We can see on the right of our slide, this is the sequence of this gene. This is the primer that we get and we use in this research. The primer is produced the amplicon size at 161 base pair, and we do the in silico analysis for the parameter. We get for the primer length and the GC% for both for the forward and reverse primer, it's 20 and 50% for GC content. And for the in silico annealing temperature, we get around 55 degrees Celsius. We can see the appearances of the Listeria monocytogenes colony in the left slide. On the brain heart infusion agar, these bacteria have creamy color with the dome shape. And in the center is the inoculum of Listeria monocytogenes in the brain heart infusion brood after 24-hour incubation with optical density 600 at 1.418. After that, we do the isolation for the DNA, and we analyze both the qualitative and the quantitative for DNA. For the qualitative analysis, we use electrophoresis, and we can see that the band appear above the marker, above the 10,000 base per marker. So it means that our isolate DNA have the size bigger than 10,000 base pair. So it's same when we check by in silico analysis that we obtain that Listeria monocytogenes strain ITCC 13932 have the genome whole genome size at around 2.9 million base pair. And for the quantitative DNA analysis, we check both of purity and concentration. For the purity, we get at 1.802, and for the concentration, we get 72 picogram per microliter. This is the step. This is the condition that we use for each step. And for the annealing temperature, we check at 53 until 62 degrees Celsius. After the PCR process, we check the amplicon with the electrophoresis. And we see that the primer can amplify from 53 degrees Celsius until 62 degrees Celsius with the size at 161 base pair. We can see at the well 5 until the well 14. And this is same with our in silico analysis that the band appear above the 100 base pair and below the 200 base pair. And when we do the in silico analysis, we get 161 base pair. So it's the same between the electrophoresis and the in silico analysis. But for the optimum temperature, we get around in range 55 degrees Celsius until 60 degrees Celsius. From our preview research, we always use 60 degrees Celsius as the annealing temperature because this temperature is a default temperature for annealing process in real-time PCR. So if we see this electrophoresis that this primer also can amplify at the 60 degrees Celsius, so we can apply the 60 degrees Celsius for this primer as an annealing temperature at the PCR process. And what we obtain from this research that the primer can amplify the fragment of ENLA gene of Listeria monocytogenes. The second, optimum annealing temperature of ENLA gene primer in range of 55 until 60 degrees Celsius based on the bright and the only a single band appear. And the last, the annealing temperature can be used to develop detection kit for Listeria monocytogenes bacteria in vegetable sample using real-time polymerase chain reaction. Thank you for your attention. Once again, I want to thank for LPPM Universitas Negeri Jakarta for founded this research. Thank you and goodbye.
Okay, thank you, Mas Jefferson, for your very informative presentation. It is interesting to talk about the topic presented in your work, but due to the time limitation, your discussion and question and answer session is up. So sorry, because I have to move to our next presenter. Success for your work, Mas Declan. And for the next presenter, we have Mbak Ismaya Krisdawati. Okay, are you there? Oh yeah, okay, Mbak Ismaya. Are you going to present by using video?
Yes, by video.
Okay. Okay.
Hello everyone, my name is Ismaya Krisdawati from Salmonella 2018 and part of Department Chemistry, Faculty of Mathematics and Natural Science, Universitas Negeri Jakarta. Today, I want to present my research about the potential of the Tox-R gene as a detection tool for Vibrio parhemolyticus in seafood. Before getting into the topic of discussion, I would like to say thanks to Kemendikbudristek for funded this research in program penelitian dasar unggulan perguruan tinggi. According to World Health Organization, estimated there was 600 million cases of foodborne disease every year all around the world. This added to 420,000 deaths caused by this disease. Besides that, food contamination in Jakarta was mostly caused by seafood consumption. One of the pathogenic bacteria that cause foodborne disease in seafood is Vibrio parhemolyticus.
Vibrio paremulticus is a rod-shaped gram-negative bacterium that moves using a single flagellum. These bacteria can cause gastroenteritis. Furthermore, because the habitat of Vibrio paremulticus is in the sea and the estuarine environment, then it can contaminate a lot of seafood such as shrimp and shellfish. Then transmission of bacteria food poisoning is due to eating undercooked or raw seafood and can also be due to cross-contamination from a hand or kitchen utensil. The gene that is the focus of research of Vibrio paremulticus is TOXR, which is located around of region 3 million with a size of 879 base pairs. For the nucleotide sequence shown on the screen, the reason I use this gene as primer for detection PCR is due to its function as virulence regulator in Vibrio paremulticus bacteria. Previous studies has also shown that TOX are involved in regulating the expression for virulent genes such as TDH, T3SS1, and T3SS2 in Vibrio paremulticus, so that the result, the primer, is expected to be specific and sensitive. This gene can be used as a primer in the polymerase chain reaction or PCR technique to increase the quantity of DNA molecule on a specific target by creating new DNA molecule that complement to the DNA molecule target. A repeating reaction involves denaturating the template and then annealing the pair of primer on a single strand of DNA target and then extending the reaction to produce DNA amplification. Annealing is critical process, so an optimal temperature is required to give maximum result to the DNA in the target region and facilitate DNA analysis. And then knowing the correct annealing temperature is expected to yield high quality DNA result and allow bacteria to be distinguished from others. A gradient PCR machine was used to know the optimal temperature primer on annealing process. The following is the method used in this research. First, the primer was designed with the National Center for Biotechnology Information, or NCBI, primer blast software. And then the primer is tested with oligo analyzer tool. The next step is ground of Vibrio paremulticus bacteria that was carried out by making a bacterial culture. After that, thermoscientific and Fusion kit was used to isolate the DNA of Vibrio paremulticus bacteria. Then a gradient PCR machine was used to amplify the TOXR gene in Vibrio paremulticus bacteria using an isolated sample. Then the radiant approach was used to optimize the PCR primers. After that, a PCR product was characterized by electrophoresis. The primer bacteria of Vibrio paremulticus was designed by taking pieces of TOXR gene with a target product of 171 base pair. The length of each oligonucleotide was 20 bases. Forward and reverse primer had the same percentage that are 50% of GC that appropriate the reference of making a primer. Then the TM of the pair primers was 58 degrees Celsius and corresponding the program's reference. Both primers did not have a different TM value, and this will guarantee the correct and specific annealing temperature in the PCR process. In the growth of Vibrio paremulticus, the enrichment was carried out using a sterile loop dipped into tristic soy broth with natrium chloride. OD600 result on figure showing bacteria growth on media that incubated within 24 hours. Then the enrichment was carried out into thiosulfate citrate bile sucrose, or TCBS, agar using spread plate technique. Vibrio paremulticus that grows characterized by the presence of green colonies on TCBS agar, which is according with the experiment. The concentration and purity of the bacterial DNA isolated from Vibrio paraboliticus were evaluating using nanodrop with purification of 1.92 and 1.85, DNA concentration of 51 nanogram per microliter and 47 nanogram per microliter was attained. The resulting DNA isolates were properly pure since they range within a suitable purification range. And then the accuracy of a sample DNA isolation process was evaluating using electrophoresis. The DNA genome of the Vibrio paraboliticus bacteria was successfully isolated, as shown in figure. Lane 1 is a DNA marker, 1 kilobase later, and then lane 2 and 3 are DNA isolate of Vibrio paraboliticus with kit Viogen, and lane 4 and 5 are DNA isolate of Vibrio paraboliticus with kit thermoscientific. The electropherogram confirmed this by displaying DNA bands. Considering its size, Vibrio paraboliticus specific DNA bands are visible in the upper section, higher than 1 kilobase marker size, indicating that the results are consistent with the data or in silico analysis of the genome size that is 3 million base pair. The next is amplification of Vibrio paraboliticus using gradient PCR and characterization with electrophoresis. The figure shown that column 1 is a marker of 100 base pair, column 2 is a control negative, column 3 is non-template control, column 4 is a positive control in the form of the primer Coronavirus Sakazaki with the Gertz gene that was designed with a 151 base pair amplicon product. And then column 4 until 14 is the result of a Vibrio paraboliticus tox gene PCR with 171 base pair at an annealing temperature of 53 until 62 degrees Celsius. And then column 15 is a marker of 100 base pair. From the electrophoresis result, it can be seen that the band at an annealing temperature range produce a relatively same band thickness. The thick and bulk and intensity indicates the quantity of DNA formed is greater, and more primer can work optimally to amplify the DNA of Vibrio paraboliticus bacteria. The optimum annealing temperature for the primer can amplify the template in the PCR process in the range of 58 until 62 degrees Celsius because the bands are stable. Therefore, 58 degrees Celsius is the most optimum annealing temperature for the PCR process if associated with an in silico analysis. And then forward and reverse primer of the tox gene has succeeded in amplifying tox gene fragment with product size of 171 base pair. So the conclusion of this research was a pair of tox gene primers from the design result was able to amplify Vibrio paraboliticus gene fragment to produce 171 base pair amplicon length. And then optimum annealing temperature of tox gene primer in the range of 58 until 62 degrees Celsius based on a breath test, the stable and only single band appear. Therefore, 58 degrees Celsius is the most optimum annealing temperature for PCR process considering with in silico analysis. Furthermore, the primer and optimal temperature that obtained were used for a real-time PCR stage in the development of sensitivity, specificity, and faster methods of detection of food poisoning bacteria in seafood. That's all for my presentation. Thank you very much.
Okay, thank you, Mbak Ismaya, for your very informative presentation. It's now time for question. We still have time for question and answer. Any question from the audience, Bapak Ibu? Yes, Pandu, silakan.
Okay, thank you, Pak Budi, for the time. First, I would like to appreciate for the good presentation for Ismaya. I would like to ask, as you mentioned in your presentation, that the primer that you use can be used for the real-time PCR stage in the development of sensitive, specific, and faster methods of detection of food poisoning bacteria in seafood. So the question is, how to prove that the primer you have designed can be sensitive and specific?
Okay, would you answer
Okay.
the question, Ismail?
Yeah, thank you, Pandu, for the great question. Okay, to prove, based on the research that I am currently do, the sensitivity of the primer design can be proven by doing a serial dilution of the bacterial DNA concentration that want to be used. Then it was tested with the PCR real time and see the lowest detection of that can be achieved by the ToxR primer pair to amplify Vibrio parahemolyticus DNA. Then to determine whether the design primer is specific, it can be done by using the primer to amplify other bacterial DNA besides Vibrio parahemolyticus. Nah, if the CT distance between the target bacteria, which is Vibrio parahemolyticus, and non-target bacteria is more than 10 cycles in the CT that display, that we can determine primer has been specifically designed. That's it.
Okay, thank you. Any other question from Mas Pandu or from the other participant? Okay, if no more questions, I would like to say thanks again, Mbak Ismaya, for your presentation. And now we are going to move to our next presenter, which is Dr. Vera Kurnia Dewi. Bu Vera, are you there? Oke, Mas Muhammad, Bu Vera gimana? Ada?
Bu Vera lagi moderator di ruangan lain.
Okay. I think we just skip her presentation, and now we move to. I think it's such a good things, right? We now can move to our last presenter, Mbak Nurul Nadia Abu Bakar. Okay, Dr. Nurul Nadia Abu Bakar. Okay, from UTM. Are you from UTM?
No, from UKM, University Kebangsaan Malaysia.
Oh, okay. From Faculty of Science and Technology.
Yeah,
right?
correct. Yeah.
Okay, also graduated from there. Okay.
Oh.
Okay. Are you going to deliver your presentation directly or by video? Okay. Thank you.
Assalamualaikum and very good afternoon to everyone. I am Nurul Nadia Abu Bakar, master student from University Kebangsaan Malaysia. My research topic is optimization of Roselle anthocyanin extraction parameter by response surface modeling and potential of stem, leaf, and calyx residue as an alternative sources of anthocyanin for different industrial sectors. As introduction, Roselle hibiscus subdarifa is a tropical plant that belongs to the family Malvaceae. Is it widely cultivated in Malaysia, Indonesia, Thailand, India, Egypt, and Africa, mainly for its calyx. It has been used for many purposes in many industries like food industry, cosmetic, medicine, and also renewable energy. Anthocyanin is one of the major phytochemical found in the Roselle. It is flavonoid group that contribute to the bright color of Roselle. Anthocyanin belong to the polar molecules, and two major anthocyanin are delphinidine 3-samobioside and cyanidine 3-samobioside. However, it can be degraded by change in pH, temperature, light, and oxygen. So to extract anthocyanin from the roselle, the extraction requirement depend on several factors such as extraction method, type and solvent, type and volume of solvent, extraction time, and also extraction temperature. So these factors are important in enhancing anthocyanin stability, maximize the yield, and also minimize the rate of degradation. So for my research, I was choose sonication as it affordable, simple, efficient, quick response time. And in order to further optimize each process, response surface methodology, RSM, and central composite experimental design, CCD, was implemented. So this illustrates my method along my research. Sample was supplied from Kuala Terengganu, Malaysia, and sample were dried and ground into powder. And then the preliminary experiment was performed by fixing one variable while the other variables varied. 3 independent variables were tested at their various screening level, which are ethanol concentration, extraction time, and also extraction temperature. So the extraction was conducted in the sonicator. The extract obtained were filtered and then evaporated to dryness using a rotary evaporator. And then finally, the extract obtained were freeze-dried. The result of the extraction process were analyzed qualitatively using UV visible spectrophotometer, and quantitative testing were carried out using the equation by using the equation from pH differential method. So from the TAC value from the pH differential method, the range selection for the parameter were made, and to further optimize each process, RSM and CCD was implemented. To validate this outcome, the experimental verification of obtained result from RSM and CCD was performed. And at the same time, optimized conditions were applied to stem, leaf, and also calyx residue. And then the TAC value from the all parts of the roselle were compared together. And the last, I was quantify and identify major component of anthocyanin, which are delphinidine 3-samobioside and cyanidine 3-samobioside by using HPLC, high performance liquid chromatography. For result and discussion, I'll start with the preliminary experiment result. First parameter is ethanol concentration. So the effect of ethanol concentration were determined by using different concentration ranging from 0% to 100% of ethanol at fixed temperature of 60 degrees Celsius and fixed extraction time of 30 minutes. So from here, we can see that the TAC tended to rise from 0% of ethanol until and peak at 75% of ethanol. So 75% ethanol concentration was chosen as the reference for the subsequent preliminary experiment. The extraction time selected in the present study for second parameter is between 10 minutes to 240 minutes at constant temperature 60 degree, and also constant ethanol concentration of 75% from the previous preliminary experiment. So the TAC increased significantly from 10 minutes to 30 minutes and was reduced beyond 30 minutes. Hence, the 30 minutes was selected in order to further study the impact of the extraction parameter. The third parameters is temperature. So the TAC was examined by using a varied temperature of 40 degrees Celsius, 60 degrees Celsius, and also 80 degrees Celsius. At 60 degrees Celsius, the TAC peaked at 30 minutes. At 40 degrees Celsius, the TAC start to increase only after 60 minutes. And for 80 degrees Celsius, the TAC value is the lowest compared to 40 and 60 degrees Celsius at any time point. So the result exhibits some stability at 60 and 40 degrees Celsius, and a mark in degradation at 80 degrees Celsius. So for my study, I have fixed the temperature at 60 degrees Celsius, and the temperature parameter is not chosen for optimization process parameter. So this is the range selection for the parameter. And the optimization process will carry out using central composite design with design metric illustrated in the table. The TAC range from 2.10 to 3.42 milligrams cyanidine triglycoside over gram dried weight. So this is the actual anthocyanin content from experimental design trial. And this is the equation that explain the obtained outcome from the central composite design. A is ethanol concentration, B is the extraction time, A and B is a single, A and B is a linear effect, A squared and B squared is a quadratic effect, AB is an interaction effect. So the positive and negative sign show the direction of each term's effect while influencing the response requires either raising or lowering factors level. This table shows the one-way analysis of variance ANOVA to determine the model accuracy, goodness of it, and also credibility. So from the software, the model is quadratic, and the results show that the model was significant with high F value, 117.52 with p-value less than 0.001. Each independent effect, A and B, together with quadratic effect, S squared and B squared, was each significantly different with a p-value less than 0.05. And then what we can see is the ethanol concentration is the most powerful factor with the p-value less than 0.0001. However, the interaction effect, which is AB, were not significant because the p-value is more than 0.05. Then the adequacy of the model was examined by evaluating R squared, adjusted R squared, and predicted R squared. As we can see, R squared is 0.9882, which is close to 1. This is the fit model and significant model, while the predicted values and also adjusted predicted R squared and also adjusted R squared more than 0.8, showing a convincing relationship between the predicted and also experimental values. And then the p-value of 0.2549 indicates insignificant lack of fit, and CV of 2.11, which is less than 10, was achieved, suggests a good reproducibility of the model. So this finding revealed that the acceptable fitness of the generated model was significant to the process factor and fits within the chosen range. Next, this is the 3D and 2D contour plot. This plot considering the interaction effect, two factors at a time. We can see the red, green, and blue colored region represent the maximum, average, and also minimum values of TAC yield. So this is a defined parabolic shape. Ethanol concentration is the main factor in the yield. The maximum yield of anthocyanin can be observed around the middle level region, red region, of ethanol concentration of 65 to 75% at extraction time between 25 to 35 minutes. This is the diagnostic plot of the residual analysis, predicted response versus actual response. So the deviation of the predicted response values from the actual response values, which were randomly distributed along and close the straight line. This demonstrating both values were in agreement and implying that the model is suitable to be used for TAC yield optimization. This is the normal probability plot. The residual will distribute along the straight line, obey the normal distribution. This is one of the basic requirements for the validity of ANOVA. The optimized condition that generated from the software, which is 70% of ethanol concentration and 30 minutes of extraction time, have been applied to roselle stem, leaf, and calyx residue. So these are the value of total anthocyanin content for all the parts of the roselle. So from here, we can see that all parts of roselle contain anthocyanin, where the most TAC are found in calyx, followed by calyx residue, and the least TAC are found in stem and also leaf. Next, the HPLC profiling for the 3 samples from different extraction conditions, run 3, run 4, run 9, were carried out. So this shows that delphinidine 3-sabobioside and cyanidine 3-sabobioside are present in all samples. Between the 2 anthocyanin, delphinidine 3-sabobioside content is the highest in all 3 extracted conditions compared to the cyanidine 3-sabobioside. As a conclusion, the optimization model showed that 70% of ethanol with extraction time 30 minutes yield the highest anthocyanin in calyx, which is 3.420 milligrams cyanidine 3-glucoside over gram dried weight. and found that all parts of the roselle contain anthocyanin. So other parts of roselle can be alternative source for anthocyanin, mainly calyx residue. And is it crucially to be fully utilized as a source of anthocyanin other than calyx, since it's oftenly discarded after being processed as a food product? That's all. Thank you so much.
Okay. Thank you, Ms. Nurul, for your very interesting presentation. And we still have about 3 minutes for question and answer. Okay, Bapak Ibu, any question for Ms. Nurul Nadia? Hello? Okay. Ms. Nurul, are you there?
Yes, Doctor.
Okay. Rose cells, I would like to confirm first. Roselle is kind of a red flower, right?
Sorry, Doctor?
Roselle is kind of a red flower.
Yeah, correct.
Okay. So in this work, you report about an approach to optimize the extraction or process of anthocyanin, right?
Yeah, right.
That's the report in this paper. So are you plan to kind of test or evaluate such kind of, for example, antibacterial, antioxidant, or other activities from the anthocyanin?
Okay. So far, actually, I'm still working on it. I'm still I'm still have a lab work. So in my plan, I want to test the TPC, total phenolic content, in roselle, and also antioxidant activities like DPPH and also FRAC.
Oh,
FRAC. In plan.
Okay. Is it on your plan to use ESR for antioxidant activities?
So far, maybe, because I don't have what do you call? I'm still in a discussion with my SV, but that is one of the plan.
Oh, okay. Thank you and good luck, Ms. Nurul.
All right,
thank you for the presentation and the discussion. And ladies and gentlemen, we are now have finally come to the end of this parallel session. So I would like to thank all the presenter and participants who Halo Mas, kedengaran suara?
Kedengaran Pak.
Okay, ladies and gentlemen, I would like to thank to all the presenter and the participants who are attending this session till the end. We now move to the end of this session. So before we close this session, the committee asked me to take the picture from all of the participants again. So please, Bapak Ibu, on your camera. So Mas Muhammad can take our best picture with smile, of course. Okay. Oke, sudah, Mas?
Gimana yang lainnya Pak? Udah siap semua?
Oke. Bapak Ibu, I would like also to inform you that the certificate can be downloaded from the conference system on September 9, 2022. Of course, for the presenter who attend this session only, right? And and once again, I would like to thank you and see you on our next SMIC 2024. Good afternoon and Assalamualaikum warahmatullahi wabarakatuh. Mas berarti ke itu ya, ke plenary lagi ya.
Iya Pak, ke plenary lagi.
Ya, silakan ya ke plenary room lagi. Terima kasih.
Distinguished ladies and gentlemen, we have reached an end of this Earth Science and Mathematics International Conference 2022. Coming to the sad part of my job to provide the closing